The first concept is the offshore floating nuclear power plant, or OFNP. The main idea of the OFNP is to integrate a nuclear reactor within a floating rig of the type commonly used for oil and gas offshore operations. Imagine a reactor and this platform, the whole plant entirely built and decommissioned in a shipyard. This could afford faster and more cost-effective plant construction. The target is less than 36 months. The design is such that we expect reduced capital cost, primarily from reduction in reinforced concrete by about 90%, as well as streamlined constructions of all the structures, systems, and components within the plant. The plant itself would be transported to the site and then moored within territorial waters, which means within 12 miles offshore, in relatively deep water, say 100 meters or more. This would make this plant insensitive to earthquakes as well as tsunamis, because tsunami waves tend to be of low amplitude when they are in deeper water. The plant would be connected to the electrical grid via a submarine AC cable, existing technology. The reactor itself could be either large design, say 1100 megawatt, or a small modular reactor, 300 megawatt, or even other design. The design shown in this slide is a 300 megawatt small modular reactor. An interesting feature of this design is that the reactor itself is located below the water line. It then becomes fairly straightforward to connect the cooling systems of the reactor to the ocean itself via a series of heat exchangers, and that ensures indefinite passive decay heat removal, an important safety feature, particularly after Fukushima. We believe that the offshore floating nuclear power plant can fundamentally change the paradigm by which nuclear power plants are licensed, constructed, operated, and ultimately decommissioned. Consider licensing. It could be a more standardized design, relatively site-independent. The construction, as already mentioned, would be in a centralized shipyard, and structural concrete is virtually eliminated, therefore eliminating a source of delays and much cost in traditional nuclear power plants. Ownership. International utility could also own a fleet of such plants and deploy them in different markets, in different countries, depending on what the needs are. In terms of operations, we envision crews with standardized training that could operate in semi-monthly or monthly shifts with onboard living quarters. In terms of safety, the risk from a loss of heat sink or earthquakes and tsunamis is greatly reduced by the design. The design also has a superior level of defense in depth because in addition to the traditional barriers, the fuel cladding, the reactor cooling system, and the containment, there are several hulls, steel hulls, that protect the reactor from external events. Finally, we believe that due to the distance from the location at which the reactor will be deployed and the population centers, as well as the favorable safety characteristics of the design, no evacuation would be needed in case of an accident. While the technical lifetime of the plant is 60 years, similar to land-based nuclear power plants, the mobility of the design can afford the possibility to track the most profitable markets with minimal local infrastructure, sort of a plug-and-play approach. Finally, the back end of the project, decommissioning. The site could be returned immediately to greenfield by transferring the nuclear power plants back to a shipyard for final decommissioning.